Hello everyone, today I'm going to be talking about the Advent of Code 2020, Day 9. The first part of the problem asks to find the first invalid number in a sequence. And the number is invalid if there are no two numbers in the previous n numbers, which they call the preamble, that sum to that number. And the preamble, which is like, for instance, the last 5 numbers, is constantly shifting. So if this is our array and the preamble is 5 numbers, then we will have these 5 numbers, and then these 5 numbers, and then these 5 numbers. And what we want to check is, are there any combinations of any of these 2 numbers in the last 5 numbers that sum to this next number. So for example, 35 plus 20, 35 plus 15, etc. And actually this pair sum thing, I'll call it, is actually very similar to day 1. So if you just go back to day 1, we also had to compute pair sums for that problem, I remember. Okay, so let's get started. So I am going to store all of the possible pair sums in a dictionary, and I'm going to compute all of the initial pair sums. And actually I'm going to compute the count of how many of these pair sums there are. Alright, so what this will have is the count of each pair sum. So for example, if we have 2 pair sums that sum to 55, this will be m2 of 55 will be 2. Okay, it will be clear in just a second why I wanted to do this. So, and by the way, this enumerate thing, it creates a counter for this loop. So you could just do like for num and r, I equals 0, I plus equals 1, right? Print num. But we don't need to do this, we can just use enumerate, which does the same thing. Okay. So if the num is not in M2, then we have found a number which there is no, we have all the possible pair sums of all the previous numbers, and there was no pair sum which summed to this number, so we're done. Okay. So now what I want to do is I want to decrease the pair sum count. I'm going to shift the whole preamble by 1 number, so I'm going to remove r of I from my map, basically, is what I want to do. So I'm going to loop through let's call this num index. Okay, so for example, my initial preamble will be this, and my number is this. And then now I'm going to shift my whole preamble to be this. So I want to remove the 35, all the sum pairs which were computed with this 35 from my dictionary. So I'm going to remove 1 entry which is related to this plus this, and then I'm going to remove 1 entry which is related to this plus this. That's what this code is doing here. So technically you wouldn't need to do this deletion thing. You could just check if the num is in M2 and the value is 0. That's also okay, but anyway, I just remove it. So if the count is 0, I just remove it from the dictionary just so I don't get confused. So anyway, this decreases the pair sum count for this number. And then we want to increase the pair sum count for the next number. So like we have removed all the pair sums related to this number. Now we've shifted the window, so we want to add all the pair sums related to this number. And every other pair sum we're just leaving there. Okay, so we're done. This was the most important part, was we were going through all of the. Okay, so we're going through the next number in the sequence, and then we're checking, was there a pair sum which was equal to this number? If there wasn't, we have found our number. Otherwise, we just have to update our dictionary of pair sums, and then we're done. And then if we didn't find anything, return that. So that's part 1. And part 2 asks us to find a continuous sequence which sums to a number. And that actually sums to the number in part 1. So in part 1, the first invalid number was 127. So we want the continuous sequence which sums to 127. Also, I want to point out this array is not sorted. Okay, so no sorting tricks. Okay. The length of the sequence is unknown, and try. Right, so we're going to try two numbers, like we're going to try these two, these two, these two, these two, then these two. Okay, and then if we try all of those and none of those combinations sum to 127, then we're going to try these three, then these three, then these three, and so on. However, one part of my implementation is like, imagine we have a very large number of numbers we want to sum together. Like we want to do these 10 and then these 10, etc. I'm thinking we don't need to resum all 10. If we have this sum of these 9 numbers, we could just do that plus this number. So it's some sort of like caching. All right. Probably if you didn't do that, you could still it's probably still solvable, but maybe the solution will be a little slower. I didn't try, so. Okay, so this is just saying I have a dictionary. So this is from start in index 0 to 0, the sum is equal to the number. Then from 1 to 1, the sequence is equal to the number. Sorry about that. So like I said, we're starting from assuming that there might be a sequence of length 2 that sums to this. We're going to try all sequences of length 2. I realize I have some like offsets here for the indexes, but all this is doing was like, if we want to know what is the sum of 35 and 20, that's going to be the sum of the sequence from, like, what's the sum of the sequence from 0 to 1? Well, it's the sum of the sequence from 0 to 0 plus the new number, plus this number. And, sorry, just equals. And if we have found our number, then we're done. So we just want the minimum of this sequence, and the sequence is r from I to I plus n, and plus the maximum of the sequence. I'm not sure if I wrote that down. I guess I wrote Yeah, so if you have the sequence, then you just return min and max of the sequence. Okay. So I have the sequence, I'm just going to return the min plus the max of it. So that's basically it. We just we keep track of the previous dictionary. Just this will make it quicker to find the sums. The sums of, like, when you're computing, like, what is the sum of 15 numbers, you can just use the sum of 14 numbers plus the next number. That's why I have this previous and current dict. And yeah, once you find a value that's equal to your target, then you just return the min of the sequence plus the max of the sequence. Alright, so that's it for day 9. Thanks for watching.